Section 6.5 is on applying systems of linear equations. So let's take a minute and just review the different methods that we have for solving a system of equations. In section 6.1 we took a look at graphing, and that's where you draw the two lines and you see at the point where they intersect each other. That's kind of fun, but it's not always very exact. It works well if the two lines cross at a nice point that is actually integers, but that's not always going to be the case. Second method we looked at was substitution, and that works well if one equation has a coefficient of 1 or -1. And remember, then you solve that equation for that variable and substitute that into the other equation. We had elimination using addition, which is a good one to use if the coefficients of one of the variables are opposites of each other. Because if they're opposites and you add them, you will eliminate or get a 0 and eliminate that variable. We also had elimination using subtraction. That's if the coefficients of one of the variables of one variable are the same. So if you subtract two numbers that are the same, you get a 0, so you would eliminate that variable. And then the last one we looked at was elimination using multiplication. And that's what you're going to use if the coefficients are not the same, opposites, -1 or 1. And that's multiplying one or both equations by some number. So what we're going to do is take a look at a couple systems of equations, and you get to choose the method you want to use. So this says determine the best method and then solve. And this is a particularly kind of ugly system of equations here because it has some fractions. So we have 2/5 x plus 6y equals 24 1/5, and 3x plus 1/2 y equals 3 1/2. Now, let's not freak out about this because we know that we can fraction bust. We know that we can multiply the equation by a number and get rid of the fractions. First thing I'd like to do is take care of these mixed numbers right here and turn those into improper fractions. So I'll start by rewriting each of the equations. 2/5 x plus 6y equals, and remember how to turn a mixed number into an improper fraction. We take the denominator, multiply it by the whole number, and then add the numerator. So 5 times 24 is 120, plus 1 gives me 121 over 5. And then my second equation turns into 3x plus 1/2 y equals 2 times 3 is 6, plus 1 is 7, 7 over 2. Now, before I start looking at elimination or having to multiply by something, I'd like to get rid of those fractions. So let's go ahead and multiply the first equation by 5, and let's multiply the second equation by 2. And I chose those numbers because those are the denominators, and it will actually cancel out or bust those fractions. So now this equation is going to turn into 2x plus 30y equals 121. So it just gets rid of my denominators and then multiplies by that one. Second equation, multiplying by 2, is going to give me 6x plus 1y equals 7. Much better looking equations, no fractions. Now, I think the best way to solve this one, I guess I could do substitution, but I really like elimination, so I think I'm going to use elimination using multiplication because my coefficients of x are not the same or opposites, nor are my coefficients of y the same or opposites. So I'm going to take, actually I need to write what I'm going to do here. It says determine the best method. I'm going to use elimination using multiplication. That's my best method. Okay, so I'm going to take my first equation and multiply this one by a -3. That's going to give me a -6x here, which will cancel out with this 6x in the second equation when I add the two equations. Okay, I'm going to move these down here so I have a little bit more room here. So that's going to give me a -6x minus 90y equals a -363. Yes, these are going to be big numbers, but that's okay. Grab your calculator. And then the second equation, 6x plus y equals 7. And I'm going to add these two equations so that I can eliminate my x's. And that's going to give me a -89y equals a -356. And when I divide, oops, sorry about that, when I divide both sides by -89, use your calculator, I get that y equals 4. All of those nasty numbers for just y equals 4. Okay, now take this 4 and plug it into either of the equations. I'm not going to use the original. It has fractions. That one had fractions. I think I'm going to plug it into here because I need to find x. One of the fun things about solving systems of equations is getting to draw little arrows. So that's going to give me 6x plus 4, which is y, is 7. Subtracting 4 on both sides, 6x equals 3. And then dividing both sides by 6, I get x equals 3 over 6, or reduce that fraction, x equals 1/2. So my final answer is the ordered pair, 1/2, comma 4. And the method I chose to use was elimination using multiplication. My next example here is 3x plus 4y equals 11 and 2x plus y equals -1. I think with this one, I kind of like the fact that there's just a y all by itself here. I think I'm going to use substitution for this one, because what I'd like to do is take this second equation and solve it for y. To get y all by itself, I'll have to subtract a 2x on each side, so that gives me y equals -2x minus 1. Let's take that, that's what y equals, and let's substitute that into the other equation. So that's going to give me 3x plus 4 times -2x minus 1 equals 11. Distribute that -4. And combine, oops, mistake, not 6, 8, sorry about that. Combine like terms. 3x minus 8x gives me 5x, minus 4 equals 11. Adding 4 to both sides. 4's cancel out. -5x equals 15. And dividing both sides by -5, x equals a -3. Let's take that -3 and plug it into this equation. I can actually use that one. I kind of like it because it's already solved for y. That's going to give me y equals -2 times x, which is -3, minus 1, or 6 minus 1, or y equals 5. So my final answer is the ordered pair, -3, 5. And I had already boxed substitution because I got to choose the method that I wanted to use. And our last example here is a word problem from your textbook. So it says the library is having a book sale. Hardcover books sell for $4 each and paperback books are $2 each. If Connie spends $26 for 8 books, how many hardcover books did she buy? So of course the first thing I'm going to do is define my variables. So I need to know how many hardcover books she bought, so the number of hardcover books. But I probably also need to define a variable for the number of paperback books, even though it's not asking me that specifically. So I can say, and I can choose whatever variables I want. I'm going to use H and P. So let H equal the number of hardcover books. And that's what I have to find. And then let P equal the number of paperback books. Okay, now let's go back to the problem here. It says Connie spent $26 and she bought a total of 8 books. The 8 books means she bought some hardcover and some paperback. So the number of hardcover books plus the number of paperback books equals 8, because that's the total number of books she bought. Hardcover, number of hardcover plus the number of paperback equals 8. Now, every hardcover book was $4. So $4 times the number of hardcover books plus, and every paperback was $2. $2 times the number of paperback books. And remember, that's money. And she spent a total of $26. Okay, so here we have our system of equations. I think I would like to I think I'm going to go ahead and solve this one using elimination. Just because I kind of like elimination. So, and I think I will, what I need to figure out is what is h. So I think if I'm going to eliminate p. So that means I'd like to multiply this equation by a -2. So that's going to give me a -2p here, and when I add it to this p, my p's will be eliminated. I'll be left with h, and h is actually what I need to find. So rewriting that first equation, -2h minus 2p equals -16. And then my original second equation. And since I made my coefficients opposite, I can add. -2h plus 4h gives me a positive 2h. My p's eliminate. -16 plus 26 gives me 10. And dividing both sides by 2, h is equal to 5. So final answer, she bought 5 hardcover books. Oops, books. Okay. And that's the way I'm going to write my answer. I don't even have to find p because the problem didn't ask for that. And I definitely don't write my answer as an ordered pair because they were asking for specifically the number of hardcover books. So in this section, which was entitled Applying Systems of Linear Equations, we reviewed all of the different methods that we have for solving a system of linear equations, and you got to choose the method you wanted to use and then use that method to solve word problems.